Paper number 3, 2016, problem number 4. This one deals with a differential equation. So what we're trying to do here is to transform this given differential equation into a different form in terms of different variables through substitution. And they tell you, which is nice, they tell you what to let z equal. So z equals y squared. So we're going to do some substituting in just a minute because we're trying to get a result that has only x's and z's in it. So we need to know what y equals. Well, y equals z to the 1/2. And what I'm going to do, since I'm trying to get dz dx, I'm going to take the derivative of both sides of that last equation. So dy dx equals 1/2 z to the negative 1/2 dz dx. So that's implicit differentiation there. Let me clean it up a little bit. Dy dx equals 1/2 z to the 1/2 dz dx. Alright, again, I'm trying to get rid of the y stuff and get everything in terms of x's and z's. So dy dx, if you look back at the original, is the same as x over, I'm just going to substitute x over y minus xy. And then I'll substitute for y. Equals 1/2 z to the 1/2 dz dx. So I've already got my dz dx in there. Just got to get rid of the y's. Well, y was z to the 1/2, so let me write that. X over z to the 1/2 minus x times y minus x times y, which is still z to the 1/2, equals, right-hand side, 1/2 z to the 1/2 dz dx. Okay, so I've got an equation that has just z's and x, so I just have to clean this up, and hopefully I'll end up with that. Well, let's see, what do I want to do here? Why don't I think I'll multiply through by z to the 1/2 to get that out of the denominator. Let me come over here on the left-hand side of the screen and do that. So multiplying every term by z to the 1/2 leaves me an x on the first term. And on the second term, it's going to be x, and z to the 1/2 times z to the 1/2 is z. On the right-hand side, multiplying by z to the 1/2 causes it to cancel, so I just end up with 1/2 dz dx. And lastly, I'm going to times through by 2 and get 2x minus 2xz equals dz dx. And I pretty much have what they wanted me to get, except I have to rearrange it. So I'll leave the dz dx on the right-hand side, dz dx, and I'll add over the minus 2xz, makes it plus 2xz equals 2x. And then I could just flip the whole thing and get what they want. So that part is done. Okay, so now on part B, what they want you to do is solve that differential equation. Well, you have several methods you can use. The simplest method, remember, is always to see if it's separable. So let me rewrite this thing. I'm going to take this result we got right there and get the dz dx by itself. So dz dx equals 2x minus 2xy, xz rather, 2x minus 2xz. And if you look at that, notice you can factor out the 2x, and if you can do that, you're going to be able to separate it. So 1 minus z. Now, to separate it, we're going to multiply both sides by dx. So 2x, 1 minus z dx. And divide both sides by 1 minus z, so we have 1/1 minus z equals 2x dx. Forgot my dz. There we go. And now it's separated. So all we have to do is integrate both sides, which shouldn't be too tough. So the integral of 1 minus z, be careful there. Remember, the integral of 1 over x is ln of x. So this is going to be ln of 1 minus z. The derivative of the inside is negative 1. Which actually goes on the bottom, but that doesn't make a difference. So it's negative ln of 1 minus z. The right-hand side, integrate that. Increase over increase, so you get 2x squared over 2, which is just x squared. And don't forget your plus c. Alright, now we have to find out what c is. Well, let's see what our condition is up here. When x is 0, y is 2. When x is 0, let me fill that in. 0 squared is 0. Y is 2. But wait a minute, we're dealing with z. Well, not a problem, because we know that, where'd it go? The relationship, there it is. Z equals y squared, so if y is 2, 2 squared is 4, z is 4. Let's plug it in. So we got negative natural log of negative 3, but it's absolute value, so negative natural log of 3, and that is our c value. Let me come over here on the far left and write what we have. For our differential equation, we have x squared plus, I'm going to flip-flop this whole thing. What I'm doing, I'm just taking this, and I'm going to flip, put my x's on the left. So I got x squared plus c, and now I can sub in my c. X squared plus negative ln 3 equals negative ln 1 minus z. Okay, so we're done, except for the fact they want you to solve this for y in terms of x. So we have to go back and do our substitution again. For z, z is y squared, so we have x squared. I'll clean this up a little bit. Minus ln 3 equals negative ln 1 minus z, so that'd be 1 minus y squared. Okay, solve for y. So, what does this mean? Well, exponentially, this would mean that e, if we're working with the right-hand side where the y is, that means the base of e here, e to the power of the right-hand side or left-hand side, e to the x squared minus ln 3 power equals. No, I think I'd rather get rid of that negative on the right's bothering me. So I'm going to multiply both sides by the negative. So we'll make this negative x squared plus ln 3 equals 1 minus y squared. Well, we're getting close. Just going to get the y by itself. Let me scroll up a little bit, get some room. Okay, so subtract the 1 over. So we got e to the negative x squared plus ln 3. And then minus 1 equals y squared, negative y squared. And now, well, I got to get rid of that negative too, don't I? So multiplying both sides by a negative gives me, the 1 becomes positive, minus e to the negative x squared plus ln 3. This is just a little messy with all the signs. Equals y squared. And finally, take the square root of both sides. So it's the square root of 1 minus e to the negative x squared plus ln 3 power. Oh, I just had an idea. We could simplify that a little bit. Equals y. And we know y is greater than 0. So we don't have to worry about plus or minus the square root. So that should be a good enough answer. Let's see if we did what we were supposed to do. Obtain an expression for y in terms of x. That works. That's the answer. Right there. And that problem is done. That was that last section, 9 marks. That seems pretty generous. That didn't take quite as long as I thought it was going to. But that is the end of problem number 4.